Hello, this is Tuba Ayhan and this video is about clocked SR latch. In the previous lecture we have seen asynchronous circuits which respond to the changes occurring in input signals at a circuit delay dependent time point during their operation. Now we want to make the circuits synchronous. So to add that synchronous facility, the circuit response can be controlled simply by adding a clock signal to the circuit. So the outputs will respond to the input levels only during the active period of a clock pulse. Here you see a clocked SR latch. So this part you have seen in the previous lecture was our original SR latch. Now we have a gated clock, so now this S and R signals are go towards our old SR latch via an AND gate. So if the clock signal is low, if it is 0, then output of this AND gate will be 0. As you recall from the previous lecture, 0, 0 at the inputs of this NOR based latch means hold your state. So when the clock is 0, this structure will hold its state. When the clock is 1, output may change depending on the value of S and R. If we follow the plot, when the clock is 1 and set signal is 1 and reset is 0, output goes high. So the latch is set. Here, when the clock is 0, the change in S or R are not reflected to the output. So when the clock is low, output Q holds its state. Then here, when the clock is high again, set is 0, reset is 1, so output is reset. At this point we have a change in set signal, and if the clock is 1, then this change at the signal will be reflected to the output. So here set is 1, reset is 0, so output is 1. Output will remain 1 until a change occurs at S, R or clock. Here, at this point clock is 1, set is 0 and reset is 1, so output is resetted. Here you see the inside structure of a NOR based SR latch circuit. The difference is the clock signals here. You can pause the video and follow the signals in this structure. We can also build an SR latch with NAND based SR. To do that, here we have our old NAND based SR latch. If you recall from the last lecture, it is active low. So using two OR gates in front of it, we can build a clocked SR latch. Here you can do the same analysis for this timing graph. When clock is 0, we have S at the output of this OR gate and we have R at the output of this OR gate. So when clock is 0, this structure works as a SR latch, but NAND based SR latch. So remember, it is active low. You can fill this plot by following the signals. And another assignment, you can draw the transistor level implementation of the circuit. To do that, you need to write the functions of Q and Q prime. For example, Q is a function of Q prime, S and clock. Similarly, Q prime is a function of R, clock, and Q. Here is another implementation of a NAND-based clocked SR. The difference is this structure is active high, not active low. The drawback of this structure is it contains more transistors than the active low version of the circuit. If you have done the previous assignment, now you can draw the transistor level implementation of this circuit and compare the transistor counts yourself. To do that, you still need to write the functions of Q and Q prime as a function of S, clock, and R